Okay, this is for section 8.3, and this is on special right triangles. We're getting into the chapter that has some trigonometry things in it, and the first thing they're going to go through is special right triangles. You will use these in here, and you will also use them in trig if any of you choose to go on. Okay, there are two special cases of right triangles that we're going to look at in here. And one is a 45, 45, 45, 45, 90 right triangle. Still right. Okay, the standard labels in trig that we use, if it has a 45, 45, 90, okay, standard labels in trig, since these two angles are the same, the side opposites, those would be the same. And if you took and did the Pythagorean theorem, okay, if we did the 1 squared plus 1 squared equals c squared, this would be 1 plus 1 equals c squared, so this would be 2. You take the square root of both sides, so c equals the square root of 2. So in trig, the standard labels are 1, 1, radical 2. What they do in geometry, okay, is we take the same right triangle, 45, 45, 90, and all we do is work with a scale factor. So if this is x and this is x, then this is x radical 2. Okay? So, example, if they say to find x, okay, and they will usually give you a picture of a 45, 45. You have to make sure that it's a 45, 45, 90. If I said this was 5 and this was 5 and this was x, okay, you got to go back up here to find if your two legs are the same. Okay, then to find that hypotenuse, all you have to do is multiply it by radical 2. Okay, so your x on this one, x would be 5 radical 2. Okay, so don't make these hard. If I give you the hypotenuse, say this was 10, and still a 45, 45, 90. If I said that was 10, look at this. Go back to this one. How would you get from this hypotenuse to this? What would you divide by? What would you divide by to get from this to this? Divide by the square root of 2, right? Okay, so if I give you this and I want to know what are the two sides, if I give you the hypotenuse, I got to divide by the square root of 2. X is 10 divided by radical 2, but you can't leave a radical down in the denominator, so you got to rationalize. You got to multiply by radical 2 over radical 2. So you get 10 radical 2 over 2 and reduce it to 5 radical 2. Okay? And you should be able to check it. If this side's 5 radical 2 and this side's 5 radical 2, that's your x. Okay? Multiply this by radical 2 and you should get 10. 5 radical 2 times radical 2 would be 5 times 2 would be 10. Yeah, that checks. Okay? So on a 45, 45, 90, if you know the leg, to get to the hypotenuse, you multiply by radical 2. If you know the hypotenuse, to get the leg, you divide by radical 2. So you're either multiplying by radical 2 or dividing by radical 2. Okay? So, example. If I said, and it's a 45, 45, 90, if I said this is 14 and 14, by sight, without doing anything, what's the hypotenuse? 14 radical 2. Don't make that hard. You just multiply by radical 2. You're either multiplying by radical 2 or you're dividing by radical 2. On this one, if I said this was 15 and I want to know what's the side, if I want to know what's this, divide by radical 2. and then you got to rationalize it. So multiply by radical 2 over radical 2. So you get 15 radical 2 over 2, and that's your answer. Don't go any further than that. That's reduced. 15 halves is reduced. You don't have to go to 7.5 radical 2, okay, or 7.5 radical. Just leave it just like that. That's reduced. So let's go back through it one more time. If they give you a side, a leg, and they want the hypotenuse, you just multiply by radical 2 on a 45, 45, 90. If they give you the hypotenuse and you want the leg, you divide by radical 2. Good? Okay, that's a 45, 45, 90. Draw a separator, big separator across there. Okay. Okay, the other special case is 30, 60, 90. 30, 60, 90 right triangles. And they also have a special relationship on the sides. Special cases, 45, 45, 90 and 30, 60, 90. Yep. Okay, so let's say you have a 30, 60, 90. Standard labels in trig. I'm going to go through those first, and then I'll show you. Standard labels in trig, the side opposite, we start out as 1. Okay, now this is an important sentence. The hypotenuse is twice that shorter leg. The shorter leg is the one opposite the smaller angle. So the hypotenuse is twice the shorter leg. Third time I'm saying it. Have you written it down yet? The hypotenuse is twice the shorter leg. Okay, the hypotenuse is twice the shorter leg. Fifth time, the hypotenuse is twice the shorter leg. Get that up here in your heads. Okay? Okay, the longer leg. And the longer leg is the one opposite the bigger angle. Okay? The longer leg is radical 3 times this shorter leg. The longer leg is radical 3 times that. Okay? And if you checked it, okay, 1 squared plus radical 3 squared, it should check by the Pythagorean theorem. 1 plus 3 equals 4. Yeah, that checks. Okay? You should always check to make sure your right triangles are check the Pythagorean theorem. The longer leg is, oh, for the statement, the longer leg, I'll say it again. I'll say it a couple more times. The longer leg is radical 3 times the shorter leg. The longer leg is radical 3 times the shorter leg.
So the short leg is 2 radical 6?
Nope, be 2 radical 3. Okay? Okay, so let's do some of these. So if I said 30, 60, 90, now you have to pay attention to what your angles are. If I gave you this was, let's say I do this, he said it was 2. I would go first to the hypotenuse. Hypotenuse is twice that shorter leg. Okay, the longer leg is radical 3 times the shorter leg. 2 radical 3. And it should check. If I did 2 squared plus 2 radical 3, that whole thing squared equals 4 squared. 2 squared would be 4. How do you square this? You square the number in front. 2 squared would be 4. Radical 3 squared is 3. 4 times 3 is 12. Does that equal 16? Yeah. Okay. I figure that, but I'm not. You might not have that bottom one. Let's say I change it. Okay, so let's say I gave you this as let's say I gave you this as 16. I would go from the hypotenuse to the shorter leg first. So the shorter leg is half the hypotenuse. The longer leg is radical 3 times that shorter leg. 8 radical 3. Okay? Let's say this is a 30, 60, 90, and let's say this one, This time I give you, this is 9. Okay, go back up here for a minute. How do you go from here to here? What would you have to divide this by to get the 1? You have to divide by radical 3, right? Okay, like to get from here to here, we'd have to divide by radical 3. So take 9 divided by radical 3. Can't leave a radical in the denominator. So we have to rationalize it. So we get 9 radical 3. Radical 3 times radical 3 is 3. Now you got to reduce 3 radical 3. So this is 3 radical 3. That's the shorter leg. The hypotenuse is twice that. 6 radical 3. And then you can check it by Pythagorean theorem. Let's try another one. Ooh, let's change it up. Here's your 30, 60, 90. Okay? I didn't draw that very good. Sorry, let me draw a little bit better. Okay, let's say this is 18. The hypotenuse is twice 36. The longer leg, and the way you can tell it, the longer leg is opposite the bigger angle. The longer leg is radical 3 times that shorter leg. 18 radical 3. Okay. Question? This, if I gave you this was 18 for the shorter leg, the hypotenuse would be twice that. And the longer leg is radical 3 times that shorter leg. Okay? Okay, so let's say I gave you, this is 15. Did I do that? Nope. Okay. Did I give you the longer leg or the shorter leg? Longer leg. How do you get from the longer leg to the... Divide by radical 3. So take 15, divide by radical 3. So I'd have 15 radical 3 over 3. 5 radical 3. Now what have I found? Shorter leg. So the shorter leg is 5 radical 3. The hypotenuse is twice that. Enough examples? Okay.